Alright, so we're back with part 2 of the Winspace G2 Gravel build with support from Winspace Bikes and Ritchey Design. This build would not have been possible without their support, so thanks again for taking a chance on this small channel. And of course, thank you all for watching. Hopefully you're getting some good value from these videos. Anyways, in part 1, which is linked down in the description, we got the frame set up, we got the internal cable routing all sorted out, we installed the headset and drifters, we installed the hydraulic brake line, and we did a full brake bleed. Now at this point, we're going to start on the drivetrain and then dial in the shifting, and then we'll start to wrap up the build and tie up all the loose ends like chopping down the steer tube, wrapping the bars, and a few other final things. So jumping right in, we need to install our bottom bracket. Now this here is a Shimano Holotech 2 style threaded bottom bracket, and it installs with a very proprietary bottom bracket tool. Now this one here is actually a road style bottom bracket, which uses a different size tool than a mountain bike style bottom bracket, and of course requires a different proprietary tool. It's a little bit frustrating once you start to accumulate several bottom bracket tools, but there's really no way around it. Grease all the threads as usual, and remember that the drive side is reverse thread and the non-drive side is regular thread for this English threaded bottom bracket, which by the way is actually backward from the pedals, which have the left side using a reverse thread. Also, if you happen to have the less common Italian threaded bottom bracket, then both sides use a regular thread. I know, it's complicated. Now the goal for the bottom bracket is 35 to 50 Newton meters, which is a lot, and I really should use a torque wrench on this, but I usually just go by feel to pretty freaking tight. Since my big torque wrench that actually has this range is a 1/2 inch drive, and I don't have an adapter down to 3/8, which is required by the Park bottom bracket tool. Now next is to install the cranks. Now this here is a GRX 2x crankset, but all Holotech type cranks install the same way. Grease the spindle and push it through the drive side. Then release the safety latch and slide on the non-drive side crank arm and preload with the compression cap so that the cranks sit nicely against the bottom bracket bearings. The goal here is to eliminate any side-to-side play, but don't go too crazy with the torque. Then incrementally tighten the crank arm bolts, alternating sides one at a time up to the specified torque. In this case, we're aiming for 12 to 15 Newton meters. Now at this point, we'll focus on the drivetrain. For this build, we're going Shimano GRX 2x, so we do need to install a front derailleur in addition to a rear. I know, crazy, right? Install the chain and feed fresh inner shift cables through the pre-routed internal cable guides. Use proper housing ferrules at the ends of the housings, and be sure to pre-stretch your cables by shifting up as tight as you can without pedaling. Now this is a pro tip that will really save you a long braking period for the shifting. Now setting up and dialing the shifting is a pretty highly documented procedure, so I won't go into too much detail here. Now basically for shifting, make sure your rear derailleur hanger is aligned by using an alignment tool, and also make sure your front derailleur is at the proper height. 1 to 2 or maybe 3 millimeters above the largest chainring. Now start with the chain in the small chainring up front and the second smallest cog on the rear. Adjust the rear cable tension using the adjustment barrel so that all the gears except the largest and the smallest shift smoothly. Now at this point, your rear derailleur tension is set. Then you want to work on the 2 endpoint cogs by adjusting the high and low limit screws. Now the goal here is to allow full range of shifting through all the gears without allowing the chain to fall off either end of the cassette. Too far out on the limit screws and the chain could easily fall off, and too far inward on the limit screws and the chain won't properly shift into the endpoint cogs. Now for the front, if you're using a bottom pull braze-on type mount, which is actually pretty common, make sure that the support screw is seated firmly up against the support plate. Now I think this is a step that's often overlooked, and it can create sloppy and imprecise shifting. Now the support screw basically establishes a secondary support point in addition to the main mounting bolt. Then put the chain onto the second smallest cog in the rear and back out the high and low limit screws on the front derailleur. We'll work on setting the front derailleur cable tension first. Try and get in the ballpark by pulling the cable as taut as you can, then use the tension adjust screw, if your derailleur has one, to get the tension just right. You should be able to smoothly shift back and forth between the front chain rings. At this point, you can start bringing the high and low limit screws inward until you start to not be able to shift, and then you want to back them out just a little bit until the shifting is smooth again. The goal here is the same as for the rear derailleur, which is to prevent the chain from falling off either the high or the low chainring. Now you might be asking, why would you do the front derailleur adjustment with the chain in the second to smallest rear cog and not the smallest or the largest cogs? Well, in my opinion, there should really never be a situation where you need to shift chain rings while you're in either extreme on the cassette. Since if you do, you'll end up severely cross-chaining, which is no good for your drivetrain or your reputation as a cyclist. Plus, it's actually a little bit more challenging to set up the front mech to be able to shift high to low and low to high while you're at either endpoint on the cassette, so I generally don't even bother trying, as you'll usually end up sacrificing shifting performance elsewhere in the system. Now this method isn't from the Shimano manual, which actually recommends a slightly different procedure, but I just find that from experience this method works pretty reliably to set up systems with front shifting. Now at this point the bike is actually almost there. Now I decided to change up the wheel set and use my Hunt 35 carbon gravel disc wheel setup with 43mm Panaracer Gravelking SKs, and for this I need to swap over the cassette, which is fairly straightforward as long as you have a chain whip and a cassette tool. Use the chain whip to hold the cassette in place as you remove the cassette lock ring. Install the desired cassette on a clean and greased free hub body and tighten the lock ring down to 40 Newton meters, or equivalently really freaking tight. So we're getting pretty close to complete now, but we do need to chop some of the steer tube down and get our stem height set up. Now this part is going to be different for everyone, and some prefer to do an initial chop, leaving lots of exposed steer tube to play around with until they find their optimal height, while others will automatically go slammed and leave no room for additional spacers. Now for me, I generally know where I like to have the handlebars, but I do prefer to have a couple of spacers above and below the stem, just so I can make fine adjustments if I need to. So what you want to do is to mark the top of the highest spacer and then remove the spacers and put another mark 2 to 3 millimeters below that line. Now this is going to be the actual cut line, and it has to be slightly lower than the highest spacer you plan to use so that the headset preload bolt will actually create the required compression in the system and avoid having a loose headset. Now for this part I always use a cutting jig, and if possible use a carbon specific hacksaw blade. But if you don't have one like me, then a regular one works pretty well too. Now carbon fiber dust is pretty nasty stuff that you definitely don't want to breathe in, especially if you're an asthmatic like me, so a respirator, while some might consider it overkill, is definitely recommended. Now once you make the cut, deburr the edges with a light sanding to smooth it out. Now keep in mind for carbon fiber forks, there's no star nut like there is on metal forks, and instead you use what's called an expansion plug to aid in preloading the headset. Now these install in the freshly cut steerer and allow for the headset top cap to thread in and create that preload compression as you set up the headset. Once you have the preload set, tighten the stem pinch bolts to the specified torque, which is usually about 5 Newton meters. Now as for bar tape, I've actually been sold on the premium Supacaz tape. It's way expensive, but I actually think it's worth it because of the bar feel that it offers and because of the included alloy compression plugs, which are just so much nicer to use than the standard finicky plastic plugs. Now everyone's got their own style of wrapping bars, but in my opinion there's only one right way to do it, which is the figure 8 method. It's really clean, and in my opinion it preserves the proper grain of the bar tape, so to speak, so that it's always in line with the natural twisting forces due to your hands on the handlebars. Now if there's any interest, I could do a detailed video on the figure 8 bar tape method, but I think there's a lot of good videos out there already. Now one of the main reasons I like this method is because it eliminates a cluttered and bulky wrap job around the brifter clamp area, since you don't need to use that extra piece of bar tape which is often included. If you do it right, you can get clean lines, no exposed bar showing through, and perfectly symmetric tape on both sides of the handlebars, if that's something that matters to you. Now for this all black color scheme on this build, I couldn't really decide what to do in terms of color, and I ultimately settled on mostly black with some splashes of oil slick and purple. And so of course we need matching cable ends for this blacked out, oil slicky purple color scheme to tie it all together. Now I'm borrowing the Specialized Power stub nose saddle from my Diverge, since it's actually the only decently nice saddle that I have, and it installs the same way that any other saddle does, using the sandwich plates on the seat post to clamp down on the parallel seat rails. Now the last step is to make sure to give it a once over and to torque all the bolts down to the proper specification. You want to try to be vigilant here, as it can be a lot since nearly every bolt on the bike has a torque spec. Now personally I would say that torquing bolts on a bike is not really the place to get lazy, and even though I don't always get all of them with the proper torque wrench, I definitely do the most critical ones like seat post, stem, handlebars, crank, brakes, and basically anything that would cause catastrophic results if it failed. So I think that's about it. Believe it or not, I think we have a bike. And I have to say, I think it came out pretty well. Now, for those of you who follow the channel week to week, I did the frame unboxing for this Winspace G2 a couple of weeks ago, and now we've done the build series. So all that's left to do is to get some decent miles on the bike and report back with a comprehensive review of the bike, which will take me a couple more weeks to complete. Now, if you like this series and you want to catch that video when it comes out, be sure to subscribe to the channel if you haven't already. And what else can I say? Thanks for sticking around to the bitter end. I hope you got something out of this mini-series, and I'll see you next time.